Hey everyone. Today I want to start out by checking in with you about our first theme for this course that we have been reading about and talking about, and that is misconceptions. We started out by taking this GS 3300 misconceptions quiz, knowing that you all are at least some people who have some experience in science or background in science. If you're interested in science as one of your concentration areas, I asked you basically how much you thought you knew about science. You made a prediction, and then I gave you 19 statements that were grounded in science, but of these statements, only one was actually true, and your job was to try to figure out which one was true. I asked you to discuss this quiz with someone else if possible, to see if you could come to a consensus and compare and contrast and see if you agreed or disagreed about which ones you thought might be true. And then I gave you access to the key for this. And usually for most people, it's surprising to kind of think about a lot of these statements. And so when I asked you to reflect on this quiz, I asked you the following questions. So based on this quiz, would you say that you have some science-related misconceptions? And of course, the answer should be yes. Even people with a PhD in science have misconceptions about some of these items. For me, for example, I actually didn't know until I originally took this quiz about 10 years ago that it was the nerves when you have pins and needles in your arm or leg. I thought that it was due to the blood flow being cut off. I actually only found out through this quiz, even as a PhD biologist, that it was actually your nerves being entrapped that causes that phenomena. So there are many, many misconceptions that all of us have, no matter how much science education we have experienced. I also asked you to think about where these misconceptions came from. For many of us, these are like things that we have heard from our parents or grandparents or other people. There's just a lot of places where they can come from. So I asked you to talk about where you thought your misconceptions came from. And then most importantly, I asked you to think about your students. So based on you and your misconceptions, do you think that your students might come to your class? Do they come with as blank slates with no prior knowledge about the phenomena that we're studying? Or do they come to our classes with prior experiences and prior knowledge, whether it's correct or incorrect? Misconceptions. What do you think? And explain your ideas there. Lastly, and most importantly, what do you think is the importance of learning about student misconceptions? I then had you read this article as part of our community of practice, something that we could all, read together. And when you get together to meet, hopefully discuss key features of this article. And so I asked you to talk about, your overall response to the article, whether it was positive or negative. What do you think about the fifth graders and their ideas and actions in this case study? Where do you think their misconceptions came from? What did you like or dislike about the teacher's choices? Is there anything else that you think the teacher could have done? What would you have done in this situation? These are all things that you could write about and talk about in your reflection. And then lastly, and this will go into, the misconceptions map, hopefully. Hopefully you're able to think about, well, what exactly is a misconception based on this article? How easy do you think it is to overturn your students' misconceptions? Probably you realize from this article that it's actually very difficult to overturn misconceptions. In fact, even for scientists, this is true. The way that inaccurate ideas in science actually get overturned is usually the people who are the champions of those inaccurate ideas eventually die. And so the scientific community then is able to move forward with the ideas that replace those inaccurate ideas. So that happens a lot of times. So even adults and even scientists have difficulty overturning their inaccurate ideas. So of course it's difficult for students to do so too. Well, why is it that misconceptions are so difficult to address? Why do you think that that's true? And then I asked you to basically compile your ideas from the misconceptions quiz experience and reading that article, Teaching for Conceptual Change. I asked you to formalize, to make kind of a formal product of your learning from those two experiences and those two resources. I asked you to basically make a concept map. And if you've never made a concept map before, or some people call it a mind map, this is basically just a product where you put the main topic at hand in the center of the paper. And that here would be misconceptions. And then you kind of let your brain go from there. What are some different topics about misconceptions that you could include in this concept map? There are so many different ways that you could go with this, but some suggestions that I have based on the quiz and that first article were, what are misconceptions? What are their characteristics? Where do they come from? You could include examples of misconceptions. How do you find out what students' misconceptions are? What are some different possibilities for how you can address them? We saw some examples of how to address students' misconceptions in that Teaching for Conceptual Change article, and you might have some ideas yourself too. I asked you to use a different color every time you added to your concept map from each resource so we could see, how your learning was changing here. What I don't want to see here, and I did see an example of this in one of the concept maps that was shared with me, where a person simply went to the internet and just Googled what are misconceptions, and that's all that was in their concept map. I want to see that this is an actual product of the resources that we are using in class. I want to see that you have actually critically thought about the articles and these other activities, and I want you to show evidence of that in your concept map. So this should be a college level thinking concept map. Your middle school students, of course, when they make their concept maps, will be showing their thinking at the middle level, but I want to see your adult level thinking on these subjects. Okay. Then I asked you to meet with your group to have a discussion about what you have, done so far and learned so far, particularly related to misconceptions, but you could also have talked about the science unit that we started, the floating and sinking science unit. And so when you're meeting with your group, and you're going to do this multiple times during the semester, these are some things that you could consider discussing. What should we have gotten out of the class activities so far? And what do you think is as the instructor's rationale for assigning you those activities? Do you think there's a reason why I'm giving these to you as people who are, who say that one of your concentration is, that you want to possibly be trained for teaching science? You may not all end up teaching science. In fact, I've heard some of you say that you actually plan to be history teachers, but maybe there may be some application for you as a history teacher, even in the application, in these activities that we've been doing. So I just want to hear, about some high-end discussion about these. And so for the science activities that we do, the model science unit, like the floating and sinking unit, where we talked about the Titanic, and then we did a lab related to floating and sinking so far. I want you to think about the science activities with two different hats. I want you to think from the perspective of the science learner, which is where your middle school students would be. But also, hopefully, there will be some things that you learn from this too about the science. And then second, I want you to think from the teacher perspective. Why am I structuring these science units the way that I am? I am intending to model for you best practices in inquiry into science concepts. Is this traditional science? Does this look like how you learned science, for example? What about a classroom where all they do is read a textbook about science and answer questions or do worksheets? How is what I'm modeling different? And so again, I'm expecting that, in your discussions, we're going to show evidence of college level and thinking about the topics, thinking like a future teaching professional. I'm looking for, the quantity and quality of your contributions in your group discussions that we have this semester. All right. Lastly, I then, at the very end, I asked you to, again, add to your concept map by critically reading a second article, Misconceptions as Barriers to Understanding Science, and add what you learned to your concept map. Again, using a different color. Why is it, do you think that I want you to use a different color when you add stuff from a new resource, do you think? Is it because, if you do this, for example, with your middle school students, what will it allow them to see if they use a different color every time they add? If you weren't sure what to include in the concept map from this article, my suggestion would be to, at the very least, incorporate the different types of misconceptions that are outlined in the article. All right. And this week, I'm assigning you to submit your misconceptions concept map to me on As You Learn. It should show evidence of learning from each of the following: the misconceptions quiz, teaching for conceptual change, and misconceptions as barriers to understanding science. If you meet with your group, this would be a wonderful thing for you to work on together if you wanted to. All right. And later at the end of this unit, this first unit, we will have an exam. And one of the essay questions will be focused on this theme of misconceptions. So that's all that I have for today. Please do not hesitate. If you have any questions about stuff, please don't hesitate to try to get in touch with me so we can talk it out. And of course, your group is always a good way. Set up, group chats and things like that. All right. I will hopefully talk to you all soon. I've gotten to meet with some of you over Zoom, which is really exciting to actually get to have a talking, moving visual to go with each of your names. So I look forward to meeting the rest of you too. All right. Take care. Talk to you soon.